So electricity and magnetism topic 4.4, digital electronics. So digital electronics, in this topic you will learn mainly about the logic gates, like, or the electronic systems. So what are logic gates? Logic gates are basically combination of the switches or arrangement of the switches. And why we call them as a logic gate, or what is the reason why the term logic is used? Because they have logic, like in either they will work or they will not work. Like either the circuit will work or circuit will not work. If a circuit is working, we'll say the circuit is on, and circuit is not working, we say circuit is off. Or we can also say when a circuit is working, we can say it is 1, and when circuit is not working, we can say it is 0. So logic of a circuit can be on and off. That's why you will find some of the switches, instead of writing on and off, it is written 0 and 1. So what is the reason why 0 and 1? When you press 0, it means that will turn off. And when you press 1, it will switch on the device, or the circuit will work. Same thing if you are using a same button to switch on and off the device, that's called a power button, and you will find this symbol. So what is the reason why this symbol is used, or the other way around, this symbol is used? So actually, when we are using a same button to switch on and off, so it is like 1. If we want to switch on, we press it one time. If we want to switch off, we'll press the next time. So it is a combination of 1 and 0. So when a same button is used to switch on and off the device, that this symbol is used on it. So it is a logic that we call them as a logic gate. The logic is that either they will work or they won't work. So logic gates are basically combination of the logics, or the switches we can also say. So if the voltage is high, we say it is on, or we represent by 1, and if voltage is low, we say off, or we can represent by 0. And there are different logic gates are there. You will learn 5 of them. The first one is AND gate. AND gate, first the circuit symbol for the AND gate and how to get the result of AND gate. AND gate is by multiplication. So if you want to get the result of AND gate, we'll get the result by multiplication of the number. Like example, if it is having 2 input and 1 output, how to get the output? If input 1 is 0, input 2 is 0. 0 multiplied by 0, so what will be the output? The output will be 0. Means if any lamp, bulb, or a device is connected here, that device will remain off. But if one of the input is 0, another one is 1, so 0 multiplied by 1, again output is 0, it means the lamp or the device will remain off. If both of the inputs are 1, so 1 multiplied by 1, 1 multiplied by 1 is actually equal to 1, and 1 means what will happen? There will be output voltage, or there will be current, and the device will be on. So how to get the result of AND gate is by multiplying the two inputs. So multiplication of the two inputs will give us the final output. So 0, 0, like if one input is 0, the other input is also 0. So 0, 0, 0 multiplied by 0 is 0. Same thing, if one of the input is 0, the other input is 1. So 0 multiplied by 1, that is also 0. Then 1 and 0, when we multiply 1 with 0, so output will be 0. And 1 multiplied by 1, so 1, 1, the output will be 1. So this table, which shows how the circuit is working with the two inputs, that is called a logic table, or also known as the truth table. So logic table gives an idea that how the circuit is working based on the inputs and the type of a logic gate which is used. So AND gate, the symbol of AND gate, you can see it is ending at letter D. So its symbol is same as like D. So 0, 0, it will be 0. 1, 0 or 0, 1, it will be 0. and 1 1 when both of the inputs are high, or 1 1 the output will be high. Is it clear the working of the AND gate? Then how we can get the output by using the two inputs? Then the second type of gate is known as a OR gate. In OR gate, how to get the result? The output of OR gate is by addition. So when we add the two inputs, by addition of the two inputs, we'll get the result. And this is a circuit symbol for OR gate. You have to learn the circuit symbol. This is how we represent the OR gate. So how to get the result? It's by addition. So like example 0 0. If in two both inputs are 0, so 0 plus 0, the output will be 0. Then if one of the input is 1, so 1 plus 0, the output will be 1. And if input 1 is 0 and input 2 is 1, so 0 plus 1, the output will be 1. And when if both inputs are 1, so 1 plus 1 is 2, but in a logic gate, what are the two options? Either the answer can be 0 or 1, like binary. Only two possibilities are there. Either it will be off the device or it will be on. So when both inputs are high, both inputs are 1, the output, like 1 plus 1 is 2, but we don't say 2. In logic gates, we say that device will work, so it will remain as 1. 1 means that it will work and 0 means it does not work. So when we want the result of the OR gate, we can get it by addition of the both inputs. So 0 plus 0, 0. 0 plus 1, 1. 1 plus 0, 1. And 1 plus 1 in a logic gate, 1 plus 1 is not 2, 1 plus 1 is 1. Because it means that this device will work. And as you can see, the previous one, for AND gate, how we were getting a result? By multiplication of the two inputs. So 0 multiplied by 0 is 0. 0 multiplied by 1 is 0. 1 multiplied by 0 is 0. 1 multiplied by 1 is 1. So in AND gate, we get the result by multiplication. And in OR gate, we get the result by addition. Is it clear? The second logic gate? OR gate, the working of the OR gate and its logic table, or known as a truth table. Then what about the NOT gate? NOT gate is called inverter. So basically inverter, it inverts the input. So if input is 0, what is opposite of 0? It will make it 1. And this is a circuit symbol, a triangle with a circle in front. And if it is 1, it will make it 0. So NOT gate is known as an inverter gate, which invert the input, and it is having one input and one output, whereas OR gate and 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 gate were having two inputs and one output. So example, if input is 0 and output, we connect a lamp. So what will be the state of the lamp? If input is 0, the output is 1, so the lamp will be on. And opposite will happen when input is 1 and we connect a lamp here, so the lamp will be off. It is 0. So if input is high, output will be low. If input is low, the output will be high. And we call that as a NOT gate, or known as inverter. Then NAND gate. What is a NAND gate? Basically, NAND gate is a combination of NOT and AND. When AND from here and AND from here combine with each other, this will give a NAND gate. So combination of NOT and AND. So if this is an AND gate, and we put a circle in front of it, what it become? It become a NAND gate. So this is input 1, This one is input 2 and here is a output. Now what happened in AND gate? If there was an AND gate, we get the result by multiplication. So input 1, input 2 and the final output, which is by inverted. So example, if we have 0, 0. So input 0, 0. So 0 multiplied by 0, what is the result? 0 multiplied by 0 is 0 according to AND gate. Because AND gate, we get the result by multiplication. But because there is an inverter at the last, what inverter will do? It will invert this and it will make it 1. Same thing, if we have 1 and 0, so input 1 is 1 and input 2 is 0. So 1 multiplied by 0, that is 0. But because there's an inverter, there's a NOT gate at the last, so what it will do? It will make it invert, it will make it 1. Same way, if we have 0 and 1, so 0 multiplied by 1 is how much? Like multiplication of 0 into 1. So that will give 0. But because the inverter is there, so it will make it 1. And when we have 1 multiplied by 1, that is equals to 1. But because there is an inverter, that inverter will make it 0. So all the output of the AND gates are inverted due to presence of the NOT gate at the last. And this gate is known as NAND gate. So NAND gate is a combination of AND and NOT. So AND from here and AND from here result in NAND gate. So all the inputs, all the output of the AND gate will be reversed because of the presence of inverter. So 0, 0, it is 0 for AND gate, but because it's a NAND gate, it will make it 1. 1, 0, the result is 0, but because there is a NOT gate inverter at the end, so it will make it 1 as well. 1, 1, it will make 1 for AND gate, but because there is an inverter, it will make it 0. So NAND gate is a combination of The NAND gate is a combination of NOT and AND. Is it clear? The logic gate, NAND gate. And the final gate is known as a NOR gate. What is a NOR gate? NOR gate is actually a combination of OR and NOT. And how we get the result for OR gate? So how we get the result for OR gate? OR gate result is by addition and that result is inverted. So example, when we draw the truth table for this, so 0 plus 0, 0 plus 0 is how much? That is 1. Sorry, 0 plus 0 is 0. But because there is an inverter, so 0 plus 0 is 0. But because there is an inverter, it will make it opposite. It will make it 1. And if we have 0 plus 1, so 0 plus 1 is 1. But because there is an inverter, it will make it opposite. If we have 1 plus 0, so 1 plus 0 is 1 and it will make it 0. And 1 plus 1, when we have 1 plus 1, in terms of logic gate, 1 plus 1 is actually 1. 1 means it is working. And because there is an inverter, it will make it 0. So all the output of the OR gates are inverted. So NOR gate is actually a combination of NOT and or. So these are the 5 logic gates which you have to learn, which include and, or, not, NAND, and NOR. So just remember how to get the result. So if there is a, you have to remember you should be able to draw the circuit symbol. So if it's an AND gate, how we get the result? We get it by multiplication. If it's an OR gate, how we get the result? By addition. If it is a NOT gate, how we get the result? By invert. If it is a NAND gate, how we get the result? By multiplication and then invert. And if it's a NOR gate, how we get the result? First by addition and then invert. So this is how we get the outputs of these logic gates. Now we'll do some questions related to logic gate. So first thing, what is important is you identify the gates from the symbol. So what is this gate which I'm pointing here? What gate is this? We have like 5 gates are there according to the symbol you can identify. We can have AND gate, we can have OR gate, NOT gate, NAND gate, and we have NOR gate. These are the logic gates which we can have. So what is this? It's easy to remember, and the letter D is this resemble with letter D. So this is actually AND gate. If it was a NOT gate, then there should be a circle here. But if it's a NAND gate, then there should be a circle here, but it is AND gate. And what about this? This is a circuit symbol for OR gate. How we get the result of AND gate? The AND gate, we get the result by multiplication. And how we get the result of OR gate? It's by addition. So in the question, the logic gates are, you have to complete this table. So how to complete the table? This is AND. Here is an OR gate, AND gate, result is by addition. Sorry, multiplication, and OR gate, result is by addition. 0, 0. So what 0, 0? What will be this result? 0 multiplied by 0. What is this result? So that will be 0. So this is 0, and so say this same 0 will be here because it's the same line. So this 0 will be here, and C is how much? C is 0. So C is 0. So this is C is connected, so that is 0. 0 plus 0, what will be the output? So 0 plus 0, the final output will be 0. And they're saying complete a column. Yeah, complete the column X for a truth table. Use a blank column for your working. Like we can work out the first, it was 0. The first output was 0. Then the second one, if A is 0, B is 1, and C is 0. So 0 multiplied by 1, or 1 multiplied by 0. What is the answer for this AND gate? So 0 multiplied by 1, that is 0. So this will be 0, and 0 plus 0. So that is 0 as well. So 0 plus 0, the final will be 0. Then we have the third one, 1, 0, and 0. 1 multiplied by 0, what is the answer? 0 multiplied by 1, or 1 multiplied by 0. So that will be 0 again. And this is also 0. So it is 0 comma 0. So the final 0 plus 0 is remains 0. Then it is 1, 1, and 0. So A is 1, B is 1 and 0. So 1 multiplied by 1 multiplied by 1 is 1. So here we have 1 and this is 0. So 1 plus 0 or 0 plus 1. So final will be 1. So this is 1 and 1. 1 multiplied by 1 is 1 here and 0. And OR gate we get result by addition. So 1 plus 0. So 1 comma 0, when it is added, it will give us 1. So final will be 1. Then 0, 0, 1. Like this is 0, and this one is 1. So 0 multiplied by 0, that is 0, and this is 1. So 0, 1, 0 plus 1, the final will be, so 1 is 0, another one is 1. So final 0 plus 1, that is equals to 1. Then 0, 1 and 1. So 0 multiplied by 1, that is 0, and this is 1. So 0 plus 0 comma 1 again. So when it is added, it will be 1. And when we check 1, 0, because if A is 1, B is 0, and C is 1. So 0 multiplied by 1, that is 0. So it will again 0 comma 1, and 0 comma 1 is actually, because 0 plus 1, so it will also give 1. And all are 1, 1. So 1 multiplied by 1 is 1, and 1 plus 1 in logic gate, 1 plus 1, we don't write 2 here. If you write 2, it is wrong, because logic gate 1 plus 1 is 1. Like if the both inputs are high, the output will be high. So in a binary, there are two possibilities: either the device will work or the device will not work. Is it clear, this question, that how we complete the table from this circuit, digital circuit diagram? So it is important that you recognize the circuit symbol, and then using a circuit symbol, you should know how to get the result. And from that result, you can work out the output for different combination. In a space below, draw a circuit symbol for thermistor. So what is the circuit symbol for thermistor? You have to learn these circuit symbols. So this is a circuit symbol which we use for thermistor. A similar question is there. You can see the similar question. So what is this gate? It's, and even it's a same circuit is there. What is this gate which is having input A and B? Which gate is this? AND, OR, NOT, NOR, or NAND? So this one is AND gate, and this one is NOR gate. So 0, 1, because it is by multiplication, and for OR it is by addition. So 0, 1, 0 multiplied by 1, what is output? D will be there. So 0 multiplied by 1 is 0. So this is 0, and C, they mention it is 1. 1 plus 0. So 1 plus 0 or 0 plus 1, that is equals to 1. And same way, 1 multiplied by 0, that is 0, and 0 plus 1, that give 1. When inputs 1 multiplied by 1 is 1, and 1 plus 0, that will give 1. And 1 multiplied by 1 is 1, and 1 plus 1 will give us 1. So all the cases, we have the high output. So this is how we complete this circuit. Is it clear?